Okay guys, we are going to start our DBMS module 2. So basically these are the notes which has been taken from the KTU notes. So if you want you can download it from there. So let's get started. So first of all we are understanding the syllabus here. Let's understand the syllabus. First of all you have to see here that the things that we are going to learn here is a structure of relational database. What are the integrity constraints? What is relational there are different constraints. Okay, the different constraints we have to learn. Then how can you make from the diagram, how can you create a relational schema? In module 1 we have learned how we will create diagram. So in this module we will see how can you synthesize relational schema from the diagram. Then we have to learn relational algebra. In the relational algebra we have to learn select, Cartesian product operation, join, equijoin, natural join, and some query example. Then we will move on to the SQL. In SQL we will be learning data definition, DDL, that is data definition. Then also we will be learning table definition operations, create, that is DDL also we will learn, SQL also we will learn. That is the main thing. And data definition languages are this: create, drop, alter, insert, delete, update. These different operations also we have to learn. Understood? So let's get started. First of all we are going to see how can you create a schema, but before that there is some theory part that you have to understand. So let's get started. First of all, lecture 1 is about relational data model. Relational data model means, we have told you there are different data models. In module 1 we have learned what are the different data models. You can have the graph model, the network model, the relational model, right? There are different data models. Relational model we have said there, this is the most popular model which is mostly used, because here the database is treated as a collection of relation. Relation is a table which represents we are representing database. We know how SQL we will represent SQL. We all know we are representing SQL through the tables. That is what relations means, tables. Relations means tables. So here we are representing the database as a collection of relation. Now relation is a table which has values in it, and rows in table is a collection of related data value. Relation is what? A table. This table has lot of values in it, and rows in a table is a collection of related data values. Now what is rows? If you see in the SQL, we have already seen SQL, that's why I'm giving examples of SQL. Not we, but most of you have done it in the lab, right? So if you see, these are my rows, 101 RAM. These are the data values. So that is what it says. Relation is a table which has values, and rows in a table is this collection of all of these. Rows is what? They are the collection of this data values. Row in a relation table is called as the tuple, and column is the attribute, and table is a relationship. Now rows, these are the tuples, tuple 1, tuple 2, tuple 3. So row is which has the related data values in it. So these are the tuples. Now the columns like employee number, name, address, mobile number, age, salary are the columns. Now these are called as the attributes, and this employee table is known as the relation name. That is the relation table name. That is the relation table is the relation. Understood? Now let's understand what are the different components of a relation database. The main components of relational database structure are this. As we have already discussed, what is tuples? Tuples are the rows, and relation is the table. Column are the attribute. These we know. Now another important components of relational database is domains and key. Now what do we mean by domain? What do we mean by key? We will learn that. First of all, we already has to discuss, these are the different, these 5 components we have to discuss clearly. So let's understand. Domain is what? Domain is a unique set of values which is permitted for an attribute in a table. That means domain means what? If you consider an attribute name, can my name be 1, 2, 3? No, because numbers cannot be named. So in my name I have to be specified that my name can only be a string, or it can only be characters. My name can be characters or string, variable characters or string. It cannot be integers and all. So domain help us to specify the values which are permitted. What are the values which are permitted for an attribute in a table? For example, if you consider the domain of month of year, the domain name, let us say it is month, the data type should be data. Values can be January, February, March. That means the data type for the year would be date, not data, it's date, okay, in date. So it's actually date for year and month and all. For dates kind of thing, the data type should be date. So the values can be only dates, like dates can only come here. So in a domain, what happened is that the only three parts are there. First you have the domain name, then you have the data type and the values. These are the three parts in the domain. So domain is nothing but it is a set of values that can be allowed for an attribute. If you consider, let us say roll number, and I want to say that roll number can only be numbers, so its data type should be integer. Roll numbers, sorry, some problems. So I will be specifying, okay, the roll numbers data type can only be integer. This is something I will be specifying. Understood? That is what. So domain has basically three types: name, data parts and data values. Okay, fine. Now if you see here, this is an example here. If you see this in this employee table, you have employee number, last name, first name, date of birth, sex, telephone number, salary as the attributes. Now what are the domain names and domain values which is allowed here? Let's say consider employee number. Okay, I'll change the color to red. Okay, consider the employee number. Now when you consider this employee number can only be integer. Okay, only be integer. Set the domain name as employee numbers. Last name can be only string, first name can only be string, date of birth, that is what it means, like date values only will be allowed, dates. So date is actually a data type. Now sex we have said, okay, it's a string. Telephone number is an integer, salary is an integer. This is something that you can give while you are creating a table, something you will give. Okay, so always a domain will have its domain, each of these attributes would have a set of data type that is allowed for it, that is actually allowed for it, that is called as domain. That is what we are discussing right now. Then I have said the domain has different parts, like the data name part of the domain, then the data type part, then the values. Understood? Now the other part in here we will discuss later. This is the part that we have discussed right now. We have only discussed the domain part. I hope the domain part is clear. Now tuple is the rows in it, which is the ordered set of value. Tuple is a portion of a table containing the data that describes only entity. Tuple is the part of the that is, these are the different entity, one entity, two entity, three entity. There are different entities in our tuple. So that means, you know, the table, the table is known as the entity type, and the different rows in here would be the entity itself. This is the first entity because it is describing the entity type employee. That is what it means. That is how you have to understand it. Okay, so you will be understanding here that tuple is a ordered set of value which is actually containing the data that is describing the entity, also known as record. Each value is derived from an appropriate domain. From the domain, on the basis of the domain, if it is integer, only integer values be there. If it is string, only string can be there, right? And if it is date of birth, only date can be. Date is the data type, means date can only be there, like that. These are coming, these data values of the records or of the tuples is coming from its appropriate domain is given here. So what is tuple? tuple is a portion of the table which is containing the data, which is actually describing only entity. Described only entity, it is basically describing. So tuple is an ordered set of values. It is some ordered set of values that is describing only the entity, the data that is describing only the entity, the portion of the table that is containing the data. Understood? That is what tuple means, and it is also known as what? These tuples are also known as the records. Understood? Now look at here. Here Kumar Singh, this 52/52 store, one C code and one telephone number is a tuple which is belonging to a customer relationship. This is a tuple. This is one some data that is describing one entity in the entity type customer. So that is why this is a tuple which is belonging to the customer. Understood? So their domain, domain, that is not here. Domain will be something which you will define while you are creating the table. Now what is columns? Column is in a table are called as the attributes or field of the relation. Now column, if you see column here, these are the different columns. These are the attributes of this relationship, or it is called as the fields of the relationship. Employee number, last name, first name, date of birth, sex, telephone number, salary are the different columns of the relation. Understood? That is the attributes of or the field of the relation. A single cell in a table called as field value, attribute value or data element. Now single cell, the single column is called as a field value, the attribute value or data element. So if you take any single cell if you take, that can be the attribute value or any data element. It can be, it is a data element, right? If you take any, if I take this can be the attributes, this I color attributes on value, or attribute is also called as field. So it can be fields value, or it's just a data element. For example, for the entity person, attributes could include eye color and height. These are the different attributes. Also person, phone numbers are also attributes itself. Okay, these are the different field value or data element or the attribute value of this. Understood? Now let's understand the another important part, that is key of a relation. Each row has a value of a data item that uniquely identifies the row in a table. Each row would be having a value of a data item that can uniquely identify that row. That is called as key. If you see here, each of these table here, 1, 2, 3, 4, these are the things that is going to uniquely identify. 1 is going to uniquely identify this row. 2, if you I'm calling 2, that means these can be repeated, right? These lot of things can be repeated, but here is the student number which is not repeated. Student number is for different student will be different. So if I'm saying student number 1, I am talking about this particular record only I will be considering. So something which can uniquely identifies that row in the table is called as the key of the relation. So each row has a value of a data item that can uniquely identifies that row in the table, that is called as key. So in the table there is one value of the data item, or it can be not just, can be set of items can also be there, not just a value of a data, it can be set of data item that can basically uniquely identifies that row in the table, that is called as the key. So which can uniquely identifies that row in the table is called as the key. Now what is relation? Relations are the tables. Okay, relations are the table, a table of values. A relation may be what? It is a table itself which has a set of rows and columns. That is, a table is perceived as a two-dimensional structure composed of rows and columns. Each row represents a fact that corresponds to a real-world entity or a relationship. Each row represents a fact. Fact means some data about the real-world entity or relationship. So each row would have the, I told you, rows are tuples. Tuples has the ordered set of values which is representing a real world entity or a relationship. So So a relation is a table of values. It can have a set of rows and document the top rows and column. This is a relation. This as a whole can be considered as a relation. That is what a relation actually means. Okay, that is what a relation actually means here. So now, so the relation is something which is going to, I just want you to understand this particular sentence. That is, what does it mean? It is going to each row represent a fact that corresponds to a real world entity or a relationship. That means if I take one, okay, if I take one one row, it will be a fact or data, a whole thing that is going to represent a real world entity student, right? Like that. So it contains, a relation contains a lot of facts that can represent a real world, represent or corresponds to a real world entity or relationship. That is what it basically do. It can represent either an entity or a relationship also. That fact can represent, because in two attributes can have a relationship in between them, so that relationship also it can represent. So it is one important thing that you have to understand. So each row represents a fact that actually corresponds to a real world entity or relationship. So each row is corresponding what? A fact that actually is something which is corresponding to a real world entity or relationship. Now let's understand here schema of a relationship, degree of a relationship, and relation schema. Schema, how do we mean by? This is actually like a blueprint, or you can say outline of how data is basically organized in the table. Like this is how we are going to denote it. That is, R represent the relation name, and these A1, A2, N are the attributes in that relationship name. That means if I have student, I will write here in the R space student relation, and the attributes of student, let's say it's roll number, and then it is name. Then I will write the next attribute like name. Then let's say it marks. So this is how we are going to denote a schema, which is giving an outline of how the data is basically organized here. Understood? Now each attribute have some domain, and now we told you each of these attributes would also have a domain in it. What data type it is basically allowed. The domain is represented like this. This is how you will represent the domain. For example, the domain of customer ID is a 6-digit number. This is just an example. Only 6-digit number is allowed for the domain in the case of customer ID. That is what it means. So here each attribute has some domain, and that domain is represented by this. Like this you will represent the domain. Okay. Now let's understand this. That is, it is known as the degree of a relation. Degree of a relation is the number of attributes in the relation. That is the degree of a relationship. For example, if in the student table ID, name, age, department number, that means there are 4 attributes. So its degree is 4. So you have, now I hope you understand what is schema. This part is done, right? About what is schema, that part is done. This part is done. Next you have the degree of relation. Degree of relation is the number of attributes in it. So this part is also done. We have understood, okay, if I have a schema in which there are 4 attributes, then the degree of the relation is what? 4. Using data type, if each of the definition, it can be written as, if I want to write the schema with data type, then ID colon integer, name colon string, age colon integer, department number colon integer. See, so I can represent ID, roll number, whatever is colon integer. If I want, I can represent string or like that. The data type I can represent with what? With the colon. I can represent the data type here. If I want to represent the schema with data type, this is how I can represent it. If I wanted to include the data type also here. Understood? Now, relational state. What do we mean by relational state? Relational state is the subset of the Cartesian product of the domains of its attribute. That means each domain contains the set of all possible values the attribute can take. So, Attribute customer name is defined over the domain of character string of maximum length 25. Domain of customer name is what? Varchar 25. Maximum length it is allowed. So relational state is the mathematical relation of degree n on the domains, that is, it is the subset of each of the Cartesian products of the domain that is defined in that relationship. So Cartesian product specifies all possible combination of values from underlying the domains. That is the important thing that you have to understand. Just all the attributes, domains will be the, that is domain of A1, A2, A3. Their Cartesian product, if you take, will get the all the possible values, combination of values from there. And their subset is the relational state. Their subset is the relation state. If I wanted to define a domain in which I want to represent that maximum length can be 25, then it's a character. For a character, I want to say that maximum length can only be 25, not more than this. This is how I represent it. Varchar 25. Varchar 25 means I am defining character string, that is character string, and the maximum length that the customer's names can be there is 25. This is how you are going to define the maximum length case. And now I hope you understand what is relational state means. Relational state is something I told you, this is the relation state. Relation state means that it will be considering the subset of all the Cartesian product of the domains is the relational state. So table is a relationship, a column header is the attribute. All possible values which is possible in a column values are domain. Row is what? Tuple, record. Table definition, that is the outline of the table, how the table is, how the data is organized in the scheme of the relationship. And populated table is how the state of the relationship is known, which is the populated table. By doing this, we will be calculating the populated table, that is the state of the relationship. I hope this much you have understood, and if you have any doubt, please say it in the comment section below. Thank you.